Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhiday Namdar, Senior College. Now, in groups and coding theory, we start with the last unit, that is coding theory. Now, third point, public key cryptography. Now, the study of secret messages, its transmission, analysis, encoding, decoding process is known as cryptography or cryptology. In 1978, Rivesh, Shamir and Edelman published a research paper, A Method for Obtaining Digital Signatures and Public Key Cryptosystems. Public key cryptosystem is a method of sending coded messages using a pair of publicly known integers. This cryptosystem is known as RSA cryptosystem by taking first letter of these three persons. This method uses Fermat's Little theorem as a basic result, which is stated here. Now, in RSA system, the method of encoding message or word is made public. This is known as public key, and only receiver can decode the message. That is, decoding key is secret. It is known only to the receiver. Now, this is the RSA algorithm. First step, select two primes P and Q. Second, compute M equal to PQ, N equal to P minus 1 into Q minus 1. Third, choose any integer s such that s and n are relatively prime, means their GCD is 1. Fourth, publish the integers s and m. Using s and m, encode the messages as follows. Divide the message into letter pairs alpha, beta and represent each pair as a number x equal to 26 into alpha plus beta in the range 0 to 675. Replace each of these numbers x by the unique integer y between 0 and m minus 1 for which y is congruent to x raised to s mod m. Send this resulting number sequence to receiver. Now these are some results that we need while using RSA algorithm. So already we have seen the definition of congruent, that A is congruent to B modulo n if n divides A minus B, where A and B are any integers and n is a natural number. So recall, if n is natural number and A, B, C, D are in Z, then A congruent to B modulo n if and only if n divides A minus B. Secondly, A is congruent to R modulo n if R is the remainder when A is divided by n. Now, if A is congruent to B modulo n, then A plus x is congruent to B plus x modulo n. Ax is congruent to Bx modulo n. At the same time, A minus x is congruent to B minus x modulo n, where x is any integer. Also, if A is congruent to B modulo n and C is congruent to D modulo n, then A plus C is congruent to B plus D modulo n. Then AC is congruent to BD modulo n and A raised to K is congruent to B raised to K mod n, where K is a positive integer. Now see one example of RSA method. Use RSA method with pairs of letters and P equal to 19, Q equal to 23, S equal to 41 to encode the message word go. Now our first step, values of P and Q, which are already given to us. Now in second stage, we calculate M equal to PQ. So it is 19 into 23, that is 437. Then n is p minus 1 into q minus 1. So again substituting, we get this answer 396. Then in third step, the value of s is 41 is given to us. Now the message is go. So it is 26 into g plus o. So it will be 26 into 6 plus 14. See how this 6 and 14 come here. So for the letters A to Z, actually we have to consider them as 0 to 25. So A, B, C, D, E, F, G. So actually G is on 7th position. But we are counting them from 0. The position of G is 6. Similarly, O is on 15th position. but as we are starting with 0, the for O it is 14. So 26 into 6 plus 14, it is 170. It is equal to x. Now we need to calculate 170 raised to 41 modulo 437. That is nothing but x raised to s mod m. It means we calculate the remainder when 170 raised to 41 is divided by 437 to get the encoded message in the form of an integer. Now 170 raised to 41 is very big number which we cannot even calculate on our calculator. So to find 170 raised to 41 when divided by 437, the remainder value we calculate it by using congruence properties. So by congruence 170 is congruent to 170 modulo 437 because 437 divides 170 minus 170. Now we do square on both sides. Now when we do square we get 170 square is congruent to 58 modulo 437. See how we get this? So we calculate 170 square which is 28900. Now divide that number by 437. Then we get some quotient and the remainder we are getting is 58 which we have written here. So this is the remainder when 170 square is divided by 437. Now we do square on both sides because we have to reach till 170 raised to 41. Now this is 170 square we got. Now next power we consider as 170 square raised to 4 congruent to 58 raised to 4 modulo 437. Now this is according to the result of congruence, that if A is congruent to B modulo n, then A raised to k is congruent to B raised to k modulo n. That means you can consider kth power on both sides. So here we have taken fourth power. So here also we have taken fourth power. That is 170 raised to 8 is congruent to 381 modulo 437. Now see how it comes. As 58 raised to 4, when we divide it by 437, we get 381 as the remainder. And by transitivity, if A is congruent to B modulo n, B is congruent to C modulo n, then we get A congruent to C modulo n. So here 58 raised to 4 is congruent to 381 modulo 437 and this already holds. So ultimately 170 raised to 8 is congruent to 381 modulo 437. Now again we do square on both sides. Then again the congruence holds. So 170 raised to 16 is congruent to 77 mod 437 in the same logic. Now one more time we do square. So 170 raised to 32 is congruent to 248 modulo 437. After taking 77 square, we divide it by 437 and find the remainder. And then by transitivity, we get this part. But actually we want 170 raised to 41. But if I do square, then I will get 170 raised to 64, which exceeds 170 raised to 41. So we use the part we have done earlier to get the power of 170 raised to 41. So I can multiply 170 raised to 32 into 170 raised to 8 into 170. So we use these equations to get the power 170 raised to 41. Now from 2 and 3, 170 raised to 8 into 170 raised to 32 is congruent to 381 into 248 modulo 437. Again, we have used one result of congruence, that A congruent to B modulo n and C congruent to D modulo n gives AC is congruent to BD modulo n. Now multiply these two numbers, divide it by 437 and find a remainder. That value is 96. So 170 raised to 32 plus 8, 40 is congruent to 96 modulo 437. But we want 170 raised to 41. So in equation 1, there is 170 raised to 1. So we multiply first and 4. So we get 170 into 170 raised to 40 is congruent to 170 into 96 modulo 437. Again do this multiplication, divide it by 437. Then we get remainder as 151. So After dividing 170 raised to 41 by 437, we get 151 as the remainder. Hence, the encoded message is 151. Now, these are some terminologies. Ciphers. The codes in cryptography are called ciphers. Plain text. The message to be transmitted is called plain text. Ciphertext. The message in secret form is called as ciphertext. Encryption. The process of converting plain text to ciphertext is called encryption or enciphering. Decryption. The process of determining the original message from the encrypted message is called decryption or deciphering. We consider Caesar cipher in which letters are specified for secrecy. Consider letters and their numbers as follows. So for A to M, 1 to 13 letters, we are denoting them by 0 to 12. So instead of 1, we are starting with 0. So for A to Z, the numbering will be like 0 to 25. Now what is encryption function? Fx is congruent modulo 26 rule. And decryption function, the inverse of fx. Now the first example, encrypt the letters NCP using encryption function fx equal to 7x plus 5 modulo 26. So here by using this function, we have to encrypt the letters NCP. Now the letter N corresponds to the number 13. So in alphabets, it is on 14th number. So as we are starting with 0, it corresponds to the number 13. So this 13 is nothing but the value of x. And for that value of x, we find what is the value of fx from 0 to 25. And the corresponding letter is the required answer. Now putting x equal to 13 here, 13 into 7, 91 plus 5, 96. But what is 96 mod 26? So divide 96 by 26. So we get 18 as the remainder. So fx will be 18 between 0 to 25. Now what is the letter corresponding to the number 18? It is nothing but S. So n is encrypted as S. Similarly, for next letter C. Now C is on third position. So C corresponds to the number 2 as we are starting with 0. So putting x equal to 2 in the same way we find fx. So 7 into 2 14 plus 5 19. So when you divide 19 by 26 we get 19 as the remainder. So what is the letter corresponding to the number 19? So it is T. Hence C is encrypted as T. Similarly, for P, it corresponds to the number 15. So putting x is 15, it is 105 plus 5, 110. So after dividing 110 by 26, the remainder is 6. So fx is 6, so corresponding letter is G. Hence P is encrypted as G. Now, one more in the same way, encrypt the message, do not pass go. Using encryption function, fx is x plus 3 modulo 26. Now, in previous question, we have to encrypt each letter separately. Now, here one message is given. So, we consider every letter in that message and then we encrypt it. The letter D corresponds to the number 3. So putting x is 3, 3 plus 3 it is 6 modulo 26. So fx will be 6. Corresponding letter is G. So D is encrypted as G. So in this way we find encryption of each letter in that message. O, N, then T, then P, A, and G. And in this way, after finding the encryption of each letter, finally we can write that message as GR, QRW, SDVV, ZR in the same order of encryption of that letter. Now, the last is decrypt the message IMN using cipher fx is equal to x plus 3 mod 26. Now here we have to decrypt the message. So whatever is the number, it is nothing but fx, and for that we have to find the corresponding value of x. Now the first is I. The letter I corresponds to the number 8. So here fx is 8. Now we find the value of x such that 8 is equal to x plus 3 mod 26. So x is equal to 5 between 0 to 25 for which this holds. Now the corresponding letter is F. So I is decrypted as F. Now the next letter is M. M corresponds to the number 12. So again fx equal to x plus 3 mod 26, that gives us 12 equal to x plus 3 mod 26. That means 12 minus x plus 3 is divisible by 26. It means 9 minus x is divisible by 26. So x equal to 9. So m is decrypted as z. Similarly, n is decrypted as k. Hence, decrypted message is fzk. So this is the end of our unit 4, that is coding theory. Thank you.